All right, Advanced Algebra 2, 4th and 5th hour. These notes are for Friday, March 20th. Okay, we're concluding our little review of what we've done so far. All right, what we have left is to solve some equations. So let's start with equations that have logs in them already. So the first question is, how do they have logs in them already? Do they have them everywhere, like number 1? Or are they missing a log, like number 2? Okay, if they have them everywhere, this would be equivalent to the exponential equation of saying 2x plus 16 equals 2 to the 5x plus 2. And if you remember, if your bases are the same, we just drop our exponents and make them the same. So we would set up the equation x plus 16 equals 5x plus 2. Okay, so what we have here when we have logs is we can think of it in the same way. We can say our bases are the same, they're both 7s, okay? It's log equals log, so we can just simply drop the arguments down and set the arguments equal. And then go about our business solving, and we'll subtract x, get 4x, we'll subtract 2, get 14. So 14 over 4 ends up being 7/2. Okay. Now, with these, remember also that you need to check your answers, because sometimes you get the extraneous answer that looks like an answer but doesn't work. So what do we have to worry about here? We got to plug this back in. Remember that this position is called the argument, and we know one thing about the argument. If you can read my handwriting, that says argument. The argument has to be positive. So when I plug 7/2 in there, 5 times 7/2 plus 2, that's a positive. And on the other side, 7/2 plus 16 will be a positive. So I know 7/2 is the correct answer. Okay. Now if we are missing a log somewhere in the problem, anywhere in the problem, if we're missing a log, then we will not do it like number 1. We will either do one of two things. You can either do the hook like I do, or you can do Mr. Patterson's slide method. Either way, we will end up with 2 to the 4th power equals x minus 7. Okay, 2 to the 4th power is 16. Add our 7, and we get an answer of 23. And now again, plug that in. 23 minus 7 is a positive, so 23 will work. Okay, so that's if we have logs in our equation. So you want to make a quick scan of the problem when you see a log in there and say, do you have them everywhere? Well, we don't. Number 3, we don't have a log on the right hand side. So that means we need to do the hook. Okay, so why don't you pause it, work this one on your own, see how you do. Okay, the hook would tell me 3 to the 3rd power equals x squared minus 6x. 3 to the 3rd power is 27. So we should recognize that that x squared and that x aren't going to disappear on us, so we're going to need to move the 27 over and do a multiply and add. And the multiply and add would be -9 and +3. Setting both of those equal to 0 would give us +9 and -3. And when I plug 9 in, I get, what do I get? I get 81 minus 54. That's a positive number. I'm not worried about what it actually is, just worried that it is positive. When I plug -3 in, square a negative, get +9, and then it would be -6 times -3, that would be +18. There's another positive, which is what I want in the argument. So both answers work. All right, on number 4, again, why don't you pause and do it on your own to see how you do. Since these are both log-based 4s, simply drop our arguments down, set them equal. We're off to the races then. Subtract x, get 2x, subtract 10, get -4. Divide by 2, we get x equals -2 if it works. And when I plug in, I get +4, which is good. It's positive. Here I get -6 plus 10. I also get +4. Now notice how we got the same answer on both sides on this one. That's one way you can check yourself. Okay. And not only does it need to be positive, it also needs to be the same answer on both sides up there. So x equals -2 is the correct solution. So we have equations that have logs everywhere. We have equations that's missing a log somewhere, which we do the hook on. And we have exponential equations. And I already kind of alluded to this earlier on problem number 1. But what we have to have happen to us here is we need our bases to be the same, and they're not. So we look to change, and we always look at the larger one. What can I do to that 125? Well, it's 5 cubed. You might have to grab a calculator and experiment a little bit there with how you can break down 125, but you'll end up getting 5 cubed. And once you get your bases the same, then we simply drop our exponents. Now remember, over here when you raise a power to power, you will multiply these, and if it calls for you to distribute, you're going to have to remember to distribute. We don't have to do that here. It's just going to be 3x. And again, we get an equation that we're experts at these. Subtract x, we get 2x, divide by 2, we get -1/2. And these are pretty easy with a calculator in your hand to plug those in and punch that in. So you would punch in 5 to the -1 1/2 power, or maybe punch in 5 to the -1.5, see what that answer is, then punch in 125 to the -1/2 power, or it might be easier to do -0.5, and see if you get the same answer. Sometimes, like number 6, you'll have to change them both. Okay, sometimes you'll have to change one side, like number 5. Sometimes you have to change them both. We've seen this enough now, we ought to be recognizing that 8 is 2 cubed and 4 is 2 squared. Now, since we have both these bases being 2, we can set our exponents equal. Well, we've got to be careful here. We've got to distribute. Be 3x plus 3 on the left, and it would be 4x plus 6 on the right. Again, doing that little step right there, again, that produces an equation that we are familiar with. We'll subtract 3x, get an x, subtract our 6, get -3. And when we plug -3 in, it should work. Now let me show you something when you plug in -3. When I plug in -3, I get 8 to the -2nd power over here. And over here I'll get 4 to the -3rd power. But now remember, 8 is 2 cubed. So this is 2 cubed to the -2nd. And 4 is 2 squared. So it's 2 squared to the -3rd. Now notice that that's a -6. That is a -6. So I know that my -3, that my solution of -3 is correct. Okay, keep at it. Hopefully we've got the issue with the videos processing corrected, but just keep at it.